Hi everyone, and welcome to the next set of slides in reference to muscles. So the last set of slides was based on muscles that were more or less related to the skull and the head, and those muscles that were related to the hyoid bone in the anterior neck. The next set of muscles we're going to talk about today are what are called the muscles of facial expression. And when we look at facial expression, we see all these various things that the face can do. We are actually relatively evolutionarily designed to recognize faces and interpret them as signs of either emotion of the individual, so maybe they're upset or happy, or also to help us with recognizing that maybe we need to be very fearful that things are getting dangerous, those sorts of things. We're also attracted to particular faces and facial expressions as well. Some key things to remember about muscles of facial expression. First is that they're not really attached to any bone. Where a lot of muscles we're going to be talking about find attachments to bony structures, generally the muscles of facial expression lie in the subcutaneous tissue and actually are attached to the skin of the face. It's due to this configuration that we can have the very diverse variations of facial expressions that we have. So in other words, they produce effects by affecting the skin, not the facial skeleton. All facial muscles receive their innervation from the facial nerve, cranial nerve 7. So they're also responsible for surrounding orifices, and I'm thinking of the eyes and mouth in particular. So the mouth is actually a sphincter, the eyes in some ways is actually a sphincter as well, and dilators. Now, because there's no deep fascia and in this face, and the superficial fascia is between the cutaneous attachments of the facial muscles is relatively loose, when we tend to have a laceration of the face, they open very large and represent look more like a very serious injury than they really are. So due to this kind of configuration, they do make the wounds look worse. In a diagram here, I have a couple of things. First is the cadaver, where we're seeing we're actually seeing the skin has been removed, and we see the various muscles of expression here under the skin. Well, under the skin meaning the skin is removed. So we see a couple of muscles here: zygomaticus major and minor, orbicularis oris, which is the sphincter muscle that surrounds the mouth, masseter, which we've already taken in the previous set of slides, another sphincter muscle, orbicularis oculi, which surrounds the eye, and so forth. In the last slide, we did have a brief discussion on the facial nerve. This is an example because I said all the muscles that are involved in facial expression are all innervated by the facial nerve. So you'll see here where the nerve trunk is, where it exits the skull. Remember, this is a cranial nerve, which means that the nerve originates from the cranium. So it exits via a foramen here and then spreads to innervate all the facial muscles and other muscles as well, which we've sort of spoken of in the last set of slides, plus many others. So you can see it spreads throughout here. Now imagine if you have any kind of trauma that happens to this nerve in any area, it will really affect any of the muscles that are involved in and around the face. So the first muscle we're going to talk about is something called occipital frontalis. And again, like I've said many times before, the name itself tends to give you an indication of a number of things, either its shape, its action, or where it is. In this case, it sort of explains where it is. So basically, occipital frontalis, the muscle lies over the occipital and the frontal bones. In between the two is a large sheet of connective tissue called the epicranial aponeurosis. The anterior belly is called frontalis, and the posterior belly is called occipitalis, both related to the bones in which they lie on top of. The posterior attachment is attached to bone, whereas the anterior attachment is strictly to soft tissue. Therefore, when the muscle is contracting or moving, it moves from the anterior attachment to the posterior attachment. So we see it here in the diagram. This represents frontalis here in the front above the eyes. And here we see in this drawing the small part of the occipitalis bone here in the back. And you'll see this vast epicranial aponeurosis, which connects the two muscles together over the vertex of the skull itself. So its attachments, occipitalis is the lateral 2/3 of the highest nuchal line of the occipital bone and the mastoid area of the temporal bone to the epicranial aponeurosis. So this is the posterior part of the muscle. The anterior part of the muscle, frontalis, arises from the epicranial aponeurosis to the fascia and skin overlying the frontal bone. The frontal bone is superior to the eyes and the eyebrows. Its functions: it draws the scalp posteriorly, which results in the elevation of the eyes. So when we have that really wide-eyed expression, when we're really scared or really excited, it's occipital frontalis that's working. It also draws the scalp anteriorly. Its innervation, as I said with all of them, facial nerve, cranial nerve 7. We see here in this diagram, we see all the things that it does. So neutrally, when nothing's happening, where the eyes are. If the medial fibers work, it rises the inner corner of the eyebrow like this. If the lateral fibers go, we get the outer corners raised. So that's the Billy Idol move or the Elvis move. And if the lateral and the medial fibers of frontalis work together, we get the raising of the eyebrows that we see here. The next one is called orbicularis oculi. So orbicularis, when you see it, means circular. Its attachments are from the medial side of the eye to the medial side of the eye. And you might be going, what? Well, when you see here in the diagram, which I'll go to first, you'll see how this muscle encircles the eye. So the attachment runs from this medial ligament here all the way around and back to that medial ligament again. There are attachments throughout the circle, which I'll be talking about, but ultimately that's the major attachment for this muscle. So as the muscle encircles the eye, it attaches at a number of places: a nasal part of the frontal bone, the frontal process of the maxilla, which is the upper jaw or the upper teeth, and the medial palpebral ligament. The second attachment, it runs through the connective tissue of the eyelids, which makes sense because it affects them. And the third is it attaches to a bone called the lacrimal bone, which we'll be taking next week in the skull lectures. Its functions is to close and squint the eye. That's its primary function. It also depresses the upper eyelid, bringing it down, elevates the lower eyelid, bringing up, so when we close our eyes. It also retracts the lower eyelid and assists in tear transport and drainage. And like all the other muscles I said, it is innervated by facial nerve, cranial nerve 7. So again, we see it here in its attachments. Here is the medial palpebral ligament here, and we see these various attachments here. And in this part here, the eye is closed, where this one, the eye is open. You can see where the muscle here works with pulling down the upper lid and pulling up the lower lid to close the eye. The next muscle is nasalis. Its attachments is from the maxilla to the cartilage of the nose and the opposite side nasalis muscle. It flares the nostril or constricts the nostril. Again, innervated by cranial nerve 7, the facial nerve. So we see it here in the diagram. On this diagram, we see it on either side of the nose. We also see it here encircling the nose. So we say it either opens the nares or the holes of the nose or constricts them. The next muscle is a muscle called zygomaticus major. Its attachments is from the zygomatic bone near the zygomatico-temporal suture to the angle of the mouth just laterally. We again will be learning the zygomatic bone and the zygomatico-temporal suture in class next week. This one does help a little bit with the smile, so it functions to elevate the angle of the mouth, which is its primary movement. It also draws laterally the angle of the mouth, so when we try to make our lips kind of straight across, and when we smile, it's angling up. And again, facial nerve, cranial nerve 7. So we see it here in the diagrams. You can see how it has the ability to pull the mouth up or across in its attachments here. We also see zygomaticus major here. There is an associated muscle called zygomaticus minor because it's smaller in size, I don't spend a whole lot of time on that one, but you can see how it can draw the mouth up. The next is buccinator or buccinator, depending on your teacher. Its attachments are to the maxilla and the mandible at the external surfaces of the alveolar processes of the molars. Remember when I passed the skull around last week in class, or this week in class, and you could see the holes where the teeth fit in when I talked about the gomphosis of the attachment of the teeth into the jaw. So think of the lateral outer surfaces of the bone around those alveolar processes at the maxilla, which is the upper jaw, and the mandible, which is the lower jaw. This is where we're talking about, and from there it goes to the lips just lateral to the angle of the mouth. What this does, it assists in chewing food by, when it contracts, it's pushing food back into the mouth and around the teeth. So we say that its function is to compress the cheek against the teeth. And again, facial nerve, cranial nerve 7. We see it here in the diagram. It's a very large muscle here. It sort of lies between the skin on the outside of the cheek and the mucous membrane that you feel on the inside of the cheek. The muscle is lying in between the two. We see it here in this diagram. Here it is in this diagram. We also see it cut here to show the teeth, here lying just behind masseter. The next muscle, we had orbicularis oculi, which was a circular muscle that went around the eye. This is orbicularis oris, which is a muscle that encircles the mouth. So we say that it completely surrounds the mouth. It has 4 parts, 2 in the upper left, upper and lower, and 2 on the right, upper and lower. These fibers basically attach transverse through, or they transverse through the tissue of the upper and lower lips. Its 2 function is first to close the mouth, and secondly, when the proper fibers contract, it makes us pucker our lips as though we were about to kiss, and that is called protracting the lips. Again, cranial nerve 7, facial nerve. So we see it here in the diagram. It encircles the mouth. You'll notice that it does not include the lips. The lips are a more fatty tissue that are influenced by this muscle in behind. This shows sort of the lips intact in this diagram we see here, and then also here in this diagram. Thank you for watching it. That's the end of the muscles for expression. So between the last slide, muscles of the head and face, and this slide deck, this is what you will be examined on in your anatomy test in week 4. Certainly bring questions forward in class if you have any, and make sure you start going through these now and charting them all out and putting them all down. And they will be reinforced in your palpation class, in your practice consolidation, probably not for another week or 2. Thanks for listening.